It's a coherence, a way to learn concepts in harmony. Welcome students. Today we will discover the properties of squares. Let us consider a square of 16 unit blocks. Looking closer, we can see that this square is composed of a side length of 4 by 4 units. Therefore, to obtain the total area covered by unit blocks within a square, we simply multiply the side length by itself. In this example, 4 multiply by 4, which gives us 16, and is pronounced as 4 square. Now, let's explore a beautiful pattern within this square and reveal the unique property of squared numbers. Notice how the total area, 4 squared, which is simply 4 multiplied by 4. This total area can be divided into a beautiful L-shaped pattern of odd unit blocks. Starting at the bottom left corner, the first layer, highlighted in red, is a single square unit. This first unit contributes a single square unit to our total area. The second L-shaped layer wraps around the first, adding 3 additional square units in purple. This contribution of 3 square units to total area. Next, the third layer contributes an additional 5 square units in green. The square grows by odd increments. Here, a new layer of 5 units contributes to the expanding total area. Finally, the fourth layer adds 7 more square units in blue, completing our L-shaped pattern. With this final addition, we have summed the first 4 odd numbers, reaching a total area of exactly 16 square units. Now we observe the pattern for 4. The square of 4 is built by adding consecutive odd numbers. We see that 16 equals 1 plus 3 plus 5 plus 7. This confirms that the sum of the first 4 odd numbers is 16. Consider another example, an area of n SQR unit blocks formed by an by n square. Now let us explore how this square is built layer by layer using odd numbers. Notice how the total area, 5 squared, can be written as a sum of odd numbers. The first layer contributes 1 square unit. The second layer adds 3 more square units. The third layer contributes 5 square units. The fourth layer adds 7 square units. The fifth layer adds 9 square units. Adding all these layers together gives a total of 25 square units. Now we observe the pattern for 5. The square of 5 is built by adding consecutive odd numbers. We see that 25 equals 1 plus 3 plus 5 plus 7 plus 9. This again confirms that the sum of the first 5 odd numbers is 25. Let us see 2 cases, 4 squared and 5 squared. Each square is formed by adding consecutive odd numbers. From these patterns, we can generalize the result. We now move from specific examples to the general form. Thus, the sum of the first n odd numbers is exactly n squared. Here, n tells us how many numbers to add. When we add the first n odd numbers, we get n squared, where n can be 1, 2, 3, 4, or any number for which we want to find the square. This formula says that if we add the first n odd numbers, we always get n squared. Let us take an example where n is 4. Therefore, first 4 natural numbers are 1, 2, 3 and 4. We use the formula 2n minus 1 to find first 4 odd numbers. Now, let's calculate the odd number terms for 4 squared using the above equation. Let us consider n equal to 1. We will substitute n in the odd number equation with 1. This will give us first odd number, that is 1. This is the first odd number. Let us consider n equal to 2. We will substitute n in the odd number equation with 2. This will give us a second odd number, that is 3. This is the second odd number. Let us consider n equal to 3. We will substitute n in the odd number equation with 3. This will give us third odd number, that is 5. This is the third odd number. Let us consider n equal to 4. We will substitute n in the odd number equation with 4. This will give us fourth odd number, that is 7. This is the fourth odd number. Now if we add all these odd numbers, we get 4 squared. Let's test your understanding of how square numbers are formed. Which of the following expressions will give the square of number 5? Option A, 1 plus 3 plus 5. Option B, 1 plus 3 plus 5 plus 7. Option C, the sum of the first 5 odd numbers. Option D, the sum of the first 6 odd numbers. The correct answer is option C. The square of 5 is the sum of the first 5 odd numbers. We have just seen an interesting pattern with odd numbers. Let's check if you can apply it. Which of the following represents the sum of the first 5 odd numbers? Option A, 5 times 2. Option B, 5 plus 5. Option C, 5 squared. Option D, 2 to the power of 5. The correct answer is option C, 5 squared. Now, let's see how this method works for larger square numbers. To find the square of 10 using this addition method, how many odd numbers must you add together? Option A, 5. Option B, 10. Option C, 20. Option D, 11. The correct answer is option B. To find the square of n, you must add the first n odd numbers. Can you use reverse logic to find the number from its square? Let's try. If the sum of the first 6 odd numbers is 36, then 36 is the square of which number? Option A, 4. Option B, 5. Option C, 6. Option D, 7. The correct answer is option C, 6. Since there are 6 odd numbers in the sequence, their sum is 6 squared. Let's apply everything we have learned to this final example. Which statement is true regarding the number 49? Option A, it is the sum of the first 10 odd numbers. Option B, it is the sum of the first 7 even numbers. Option C, it is the sum of the first 7 odd numbers. Option D, it is the sum of the first 10 even numbers. The correct answer is option C. Since 7 squared is 49, it is the sum of the first 7 odd numbers. Thank you for watching this video. Subscribe and stay tuned for the next session. We'll see you there.